Hello students, today we'll start our next chapter, that is chapter number 4, linear equation in two variables. So let's start with the introduction. A linear equation in two variables is of the form ax plus by plus c is equals to 0, where a, b, c are real numbers and a is not equals to 0 and b is not equals to 0. So let's discuss in detail. The standard form of the linear equation in two variables is ax plus by plus c is equals to 0, where we used to say it linear equation. Why? Because the degree of x and y here is 1, and here we are having two variables x and y. That's why we called it as linear equation in two variables. Here a and b should not be equals to 0, because if suppose a is 0, then this equation is the linear equation in one variable only, and if b is 0, then also this equation is linear equation in one variable only. That's why a and b should not be equals to 0. What a and b are? A and b are coefficients of x and y respectively, and c is the constant term. And here ax plus by plus c is equals to equal. That means our left hand side is equals to the right hand side. Fine. So let's solve the example of linear equation to find the solution of a linear equation in two variables. Our linear equation is of the form ax plus by plus c is equals to 0. So let's take an example. 4x plus 2y is equals to 12. So this is the example of linear equation in two variables, because here the degree is 1. Fine, and we are having two variables, and this we can write in this way also. How? 4x plus 2y minus 12 is equals to 0. So this is a linear equation in two variables. And if we put the value of x as 2 and y also 2, and if we'll solve them, let's see what will come. 4 into 2 plus 2 into 2 is equals to 12. 4 2s are 8 plus 2 2s are 4, and 8 plus 4 is equals to 12. So here we have noticed that our left hand side is equals to right hand side. So any ordered pair x comma y can be considered as solution if it satisfies the equation. Means any value of x and y which satisfies the equation is known as the solution of the linear equation. Fine. So other examples of the solution of this linear equations are 1 comma 4, 0 comma 6, 3 comma 0. If we'll put the value of x as 1 and y as 4, then see 4 1s are 4 plus 2 4s are 8, and 8 plus 4 is equals to 12. So this is also the solution of the linear equation. Then another example, 0 comma 6. If we'll put x as 0, then 4 zeros are 0 plus 2 6 are 12. Then our left hand side is equals to the right hand side. Therefore 0 comma 6 is also the solution of this equation. Then 3 comma 0. If we'll put x is equals to 3, 4 3s are 12 plus y is equals to 0, then 2 zeros are 0. So 12 plus 0 is equals to 12. Here also our left hand side is equals to the right hand side. Therefore 3 comma 0 is also the solution of the equation. So in general, any linear equation in two variables will have infinitely many solutions. Fine. So now let's move towards graphical representation of linear equations in two variables. A linear equation in two variables is represented as a line on the Cartesian plane. A minimum of 2 points, two ordered pairs are needed to plot a graph of a linear equation in two variables. So let's discuss in detail. So here we are taking an example of a linear equation in two variables, that is x plus 3y minus 6 is equals to 0. So we can take any value of x, and if we'll put that value, then accordingly the value of y will come. Similarly, if we can take any value of y and we'll put in this equation, then accordingly the value of x will come. Fine. So we will take here x is equals to -6, and if we'll solve by taking x is equals to -6, then the value of y will come as 4. So the ordered pair -6, 4 is the solution of the given equation. Then another example is, if we'll take y is 3 and putting y is equals to 3, if we'll solve this, then the value of x will come -3. Then the ordered pair -3, 3 is the solution of the given equation. Then another example, if we'll take y is equals to 0 and putting that, if we'll solve, then the value of x will come 6. So 6, 0 is the solution of the given equation. Fine. So, and if we'll plot these points, -6, 4, -3, 3 and 6, 0, we'll draw a line and we'll notice that this line is straight. So the graphical representation of this equation is a straight line. Fine. And if we'll take a point, this is 3, 1. If we'll put x as 3 and y as 1, then the value will come as 6. And if x plus 3y is equals to 6, because here it is -6, and if this goes this side, then this becomes +6. So our left hand side is equals to the right hand side. Therefore 3, 1 is the solution of the linear equation. Fine. Then if I talk about, if we'll take a point that is not on this straight line, that is 1, 2, then here if we'll put the value of x as 1 and y as 2, then the value of x plus 3y will come 7, and which is not equals to 6. Therefore left hand side is not equals to right hand side. Therefore 1, 2 is not the solution of the linear equation. Fine. Then from these, this is clear that every point that satisfies the linear equation lies on the line. Every point that lies on the line is a solution of the linear equation. A point that does not lie on the line is not a solution of the linear equation. Note, the word linear originates from the fact that the graph of a linear equation in two variables is represented by a straight line. So here ax plus by plus c is equals to 0. This is represented by this straight line. Fine. Then lines parallel to x-axis and y-axis. Here if we'll draw x is equals to 1, then x is equals to 2, then x is equals to 5, x is equals to -3. These lines are parallel to the y-axis. Therefore any line parallel to the y-axis is of the form x is equals to k, where k can be negative or positive. The equation of the y-axis is x is equals to 0. Similarly, if we'll draw the lines parallel to the x-axis, then these are y is equals to 2, y is equals to 3, y is equals to -2. Therefore, the equation of any line parallel to x-axis is of the form y is equals to k, where k can be positive or negative as well. Then the equation of the y-axis is x is equals to 0. Similarly, the equation of the x-axis is y is equals to 0. So this is all about the introduction of this chapter. Thank you.